We are still discussing on the programming fundamentals for business. And so today we're going to be talking about what I describe as software environment, or what you can say the stages that a software pass through before it's made available to the user. And as you can see on my screen, we have the development stage. This is the stage where the software is still in your computer, the programmer's computer, the developer's computer. The software is still there. Then you also have the testing phase. This is at the phase where maybe you have finished a particular feature and you want to test it. This part of this testing is majorly done by the programmer and those that are directly involved in the production or the development of the software. Then we also have the staging stage or staging phase, where if you see a program, most of the times if you go to a place like a Google Play Store, you see a software that says at the beta phase. It means it is being tested. It is similar to the testing phase, but it's being tested by a small group of people. A small group of people, maybe other developers or people that are supposed to be owners of the software or testing it for a particular purpose. So it is not yet made available to the public for use. Then the final stage is the stage where you make it available in the public, host it in the server or something that others can have access to. So when you do that, you have done what we call, or you have moved it to the production environment. It is now at the production stage. It's now producing something for people to be able to see. So we move from the software move from development phase, development environment, and pass through testing, staging, and then move to production environment. Then we also have the software development life cycle. How in that first stage of development, how do things go? It's a structured process that programmers have to follow to design, develop, test, and maintain a software. So you can see that it involves the first three stages that we talked about: the development, the testing, the staging. It involves all those things, and it is done systematically to meet the user's requirement or to meet the requirement of those that are involved. And for you to do that, you have to do planning. There's need for planning to identify the goals, the things that you want them to do. Somebody say, I want a software. And you don't just go ahead and start building the software. You have to plan. You have to ask questions, do feasibility studies, check the number of resources that it will take you, and the timeline. How long will it take? You estimate all these things. Then gather the document, that's requirement analysis. Gather the document that you need, do interview, do questionnaire, ask people questions of what needs, of what they feel about the development of that kind of software. If it is already existing, what improvement they need for that kind of software. And then stakeholders, if it's something that will involve people to invest, something that will involve the use of outsiders, you ask them. Even if it's for internal use of an organization, you ask the staff that are already existing there. Because the thing about software is that it's either you're building on an already existing automation, already existing software, or you are moving from manual to digital. You are digitalizing the system. You are moving from manual to automation. Then if you have done all that, you start the design. One of the things that affect young programmers is that most of the time they feel that when you do this first two stages, you're wasting time. You just run straight to programming, and then run straight to design, then you will have a lot of problems. Even at the design stage, what is expected of you is high-level model from one stage to the other. What details of what is going to be done, or something like a flow chart, something like a diagram of what should be done first, the next thing that should follow, how the systems the parts of the system are related together. Those are the things you see in the design phase. And then after that, you now implement and develop. You compile, build the actual code, write the code, adhering to the guidelines that are already been set. Then you now move to testing. You can see the objective and the activities that are outlined in the video. Testing, sometimes some people separate testing from integration, but they can be the same thing. So you are integrating it to a particular software, you are testing it. All these things are things that you do in software development. And then you move to deployment. Deployment is the process where you're moving it from development to a production environment. You release it to those that owns it or to the public for public use. Then there are models in software. Before we talk about model, you also talk about maintenance. It is not enough, just like every system, a house, a car, it is not enough to buy a car, it is not enough to build a software. You have to maintain it. There's need for maintenance, there's need for a security fixing. That's why you see most of these are products, Dogo, Samsung, they will tell you security fix has been done, update. So there's need to continuously update our software to meet the current need and to be efficient and effective for the user to use. When we talk about software development lifecycle model like patterns that people have been following. I'll just talk about them briefly. One of them is waterfall model. It follows a sequential and linear process in each phase until it is completed. Sequential means each particular feature or phase must be finished before you start the other one. That's the summary of the waterfall model. Then you have agile. Agile is iterative. You go back and forth, you check, you design, you check whether it is okay. You're flexible, the requirement can change at the middle. It is not the same with waterfall. But spiral model combines the iterative development of agile with risk analysis. What are the necessary risks that involve whether we are starting afresh, we are doing it iterative, we are repeating a task, we did something wrong, we want to start it again, to check all those ones. Then we have DevOps, which focuses on continuous integration, continuous development, and collaboration between development and operations. So there's the need to collaborate in DevOps, you collaborate with the development and the operation. And each of these phases ensures systematic development. It ensures that risk is reduced, the software quality is improved, and that the project meets the client expectation. You can use any of this model to build a software, either waterfall, agile, spiral, and development. But most of the time, young programmers prefer to use agile. Then the next one is coding convention. How we're talking about coding conventions are the coding conventions, that's rules and guidelines that will help to ensure readability, consistency, and maintainability of code. Guideline that someone can follow to maintain the readability of code. So it is necessary to have those rules. So, but because we are talking about programming for business, or programming for data analytics, or programming for machine learning, we will focus on conventions in Python. One of the conventions in Python is what we call naming convention, the rules you have to follow. One, we have different rules for variables and functions, they are related. If you are creating a variable in Python, it has to start with lowercase, or what some people call small letters, lowercase. or lowercase separated by underscore, like you can see snake and snake here. Also, you can, like you can see snake here and snake here, snake case here. Those are the ways to name either a variable or a function in Python. If it is a class, it starts with an uppercase, or you can use what we call camel case for a class. If it is a constant, it has to be capital letter all through, or capital letter separated by underscore, but everything inside it must have a capital letter. Python, in its uniqueness, respects indentation. Indentation is Python, or is part of Python. If you are saying that you're coding in Python without indentation, you are started making the biggest error. So you need to give force spaces if something is inside a function. You need to give like force spaces to be able to show that these write-ups these other codes are under the function, are under the class, and all that. While in other programming languages, you can use curly braces to separate functions of different kinds. In Python, what separates is indentation and space. So white space, we should avoid unnecessary white space. We should handle error using try and except blocks. That's how to handle error. That's the way to handle error in Python. So we talk about basic concept in Python. We talk about variable. Variable is a temporary memory space. You can see the examples here. Age equal to 25, age equal to John. Remember, okay, I'll discuss that when we get to data types. Then we'll talk about data types. So the data type, the data that you supply to a variable will determine the data type, because Python is dynamically typed. So it means it is the data type of that particular variable is determined from the value of that variable. For instance, this is X, which is the variable, and this is the data type for X. This is data type for X, and this is the data, the value of X. Value of X is 10, and X is an integer, is a whole number, is an integer. And so you are automatically saying that since 10 is an integer, X is going to be an integer. Also, you can talk about float. Float means number represents decimal numbers, numbers that have a decimal number. And you can see an example here of pi. You know, pi is a constant. So this is the example. Then another one, we talk of string. String can be represented in two ways, either with double quotes or single quote. So the name here represents a string because the value is a string. We also have Boolean. Boolean gives you only two values, either true or false. Then we also have what we call collection data type in Python. The first one is a list. A list is an ordered, mutable collection of items. Ordered means it goes line by line. Mutable means it can change. It can change. You can change it while the program is running. Then we have tuple. Tuple is an unordered, immutable collection of items. Tuple is an ordered, immutable collection of items. So it means that it is ordered. It has positioned items in it, have position, and the but it cannot change while it is running. You cannot change the value of a tuple while it is running. So you can see the difference. A list is represented with square bracket, while a tuple is represented with a tuple is represented with um, okay, while a tuple is represented with parentheses. Then we also have a dictionary which talk about key and value pair. This is an example of a dictionary. The left side of the dictionary, for instance, name is the key. Here, name is the key, while John is the value. Age is the key, while 25 is the value. What separates a key from the value is the colon. Then we also have set. Set is an unordered collection of unique items. Not just a collection of items, but an unordered collection of unique items. Then another thing is we have what we call typecasting. Typecasting, which means typecasting means I can change one type to another. So how do you do typecasting? Is to put the name of the, is to declare a type like x is equals to 5, and then if I want to change it to a float, it is now going to give me 5.0. I just need to say whatever variable I want to use, in this case y, equal to float, then in bracket, and put the value I want to convert to float. If I want to do a string, I just type str. They will also talk about operators. Operators, arithmetic operators, we have plus, minus, asterisk, which is multiplication, division, percentage, and then we have explanation. We have floor division. Then there's comparison operator, equal to, that's double equal to, trying to check whether two things are the same. Not necessarily they are data types. They are just the same. They have the same value. Then not equal to, greater than, less than, greater than or equal to, less than or equal to. And then we also have logical operators. Logical operators, and or not. And means two things or three things must be the same, must meet the criteria for that particular code to work. Or means either of them can work. Not means nothing is working. Not, it doesn't need anything there to work. And then we have assignment operators. Assignment operators, we have the equal to, the plus before equal to means we'll use it much later, but it means you're saying something is at the other side. It's like saying x is equals to s plus 1. So in Python and most programming languages, you can actually write x plus equal to 1. It means s is equals to x plus 1. So the same thing for the minus, the same thing for minus equal to, the same thing for the exponential, that's times equal to, the same thing for the division equal to. Then we have what we call an expression. We have what we call a statement. Price is equals to 500 is a combination of many expressions. Price is an expression, equal to is an expression, 5 is an expression. But a statement is a group of expressions. So price equal to 500 is an expression. We also have what we call control structure. In control structure, we are talking about the system by which things should flow, the way things ought to flow in a programming language. So control structure is the way we want the flow of the program to be. So we have three types of control structure. We have sequential, which is the method means do the first line, enter the second line, do the third line, enter, just follow it sequentially, line by line, one after the other. You must finish one before you enter the other one. Then selection is for us to make decision and branching. Mind you that sequential is the default way programs run. Then selection is for decision making and branching. Say, for instance, you say if something is this, it should do this. Else, it should do another thing. So that is for Python. That is the major thing we use there. But in other programming languages like Java, you may have switch. I think also in JavaScript, you may also have switch. Then we have repetition. Repetition is for iteration, for looping, for repeating a piece of code multiple times. If there is a need to design a code that will be repeating itself multiple times, you use repetition. And for repetition, we have the for loop, we have the while, and the do while loop. All these three will be implemented as we go to the practical aspect. We also have Python function. You define, it's a kind of a reusable code. Functions are reusable code to perform a particular task. So you use the word def to define a function in Python. You use the word def to define a function in Python, and then followed by brackets that indicate whether it will have parameter or empty. So parameter are kind of here. This is a parameter. This is the syntax of a function. Whatever you put here is called a parameter, but when you are calling the function, you see the name of the function is what you use, and then the values for those variables that are parameters becomes the argument. Then we talk about data structure. Data structure is the way of organizing and structuring and managing data in a computer so that it can be stored efficiently. I talk about the relationship, the layout, and the operation that can be performed on the particular data. It is the data structure that determines that the kind of algorithm that can be done on it, whether searching, sorting, and modifying it. So we have our primitive data structure that is more like a general data structure. We have the int, the float, and the character. Then we also have the non-primitive. Okay, among the primitive, you have the Boolean. So we also have the non-primitive, which are the linear. Among the non-primitive, why we call them non-primitive, they are kind of complex. Their structure is built using the primitive data type. So we have the linear data structure. Elements are arranged sequentially. One of them is arrays, fixed size, continuous memory allocation. We have linked list, dynamic size, with elements pointing to the next. We also have stacks, which is stack is like when you are arranging chairs, plastic chairs on each other. It operates with the principle of first in, first out. Last in, first out. Then we have queues. So some of these things are not different from what you see. If you think of queue in a filling station, you already know what a queue is. In the real sense, in the purest form of it, the stack, the last to enter, the last share you start on something is on each other is the last share. If you are going to remove them, is the last that you pull out. But in a queue, in the purest form of it, the first person that entered the queue, whether it's a line in the bank or it's a line of cars in a filling station, the first person to enter should be the first person to be attended to, which means you operate with the principle of first in, first out, while a stack operates with the principle of last in, first out. Then we also have non-linear data structure, like the tree, like the graphs. What is the purpose then of data structure? Well, we have said it before, for efficient data storage, for optimized algorithm, and for data manipulation. Example of common operation on data structure. We have the insertion, we have the delete, we have the transversal, we have the searching, we have the sorting. The insertion talks about adding an element to the data structure, while the deletion, you are removing. Transversing, you are trying to access, you are trying to process. Search, you are finding something. Sort, you are arranging things in a specific order. We need to be able to use data structure efficiently so that we can create optimized software that will define how data can be handled during execution. So let's talk about the data structure. We have arrays. An array is a collection of items or data stored in continuous, that's connected memory storage, continuous or connected memory storage. The first, because we are using Python, in Python there's no specific data type or data structure that is called an array, but we have a list, we have a tuple, we have list, we have tuple, we have talked about this before. We have set, we have dictionary. We have set, we have dictionary, and these are things that we can use in Python to represent an array. Now, we also talk about linked list. A linked list is a linear data structure, as we have said before, where each element is connected to the other by a nest. But the data and the pointer that connects are together called a node. As you can see the diagram, this is the diagram of a node. This is the diagram of a node. The node has the data and the nest. You can also see the diagram of a linked list. This is also another diagram representing a linked list. So we have various types of linked lists. We have the single linked list. Each node points to the next node. We also have the double linked list, where each node points to both the next and the previous node. We also have a circular linked list. The last node points back to the first node, forming a circular structure. What are the advantages of linked list? It has a dynamic size, it has efficient insertion and deletion operation. I also have a problem. One of the problems is that there's memory overhead, which means each node requires additional memory for the pointer or reference. You can call it pointer, you can call it reference to the next node. It has slow access time. It's not as fast as other data type. So we can implement node in Python by using this particular code here. We're going to test it much later when we practicalize some of these things. But these are just code to show how you can implement linked lists in Python. So we'll talk about stack. You can see it is rising from 0 to 5. This is the index of the stack, and we have already said that stack operates with the principle of last in, first out. So assuming these are shares that you have arranged together, the first share on index 0 is 9, and so on and so forth. So if I want to remove a share, this is the top. I'm going to go up and remove the first one, which is 10. So we have push. Push operation is to add an item. Pop operation is to remove. Pick operation is to return the top item without removing it. And its empty is to check whether the stack is empty. You see the advantages here. Simple implementation, efficient operation. The disadvantage is that it has limited access. Only the top element can be accessed directly. That is one of the memory limitation. Can be implemented in Python this way, this code. Then we'll talk about queue. A queue is a linear data structure that follows the FIFO, first in, first out principle element. First in, first out principle. You add elements to the rear of the queue and you remove from the front. So the back of the queue is called a rear and the front of the queue is called a front or the beginning. The rear can be called the end. So operations and queue items to add items, the queue item to remove, pick, return the front item without removing it is empty. We check whether the queue is empty. Its advantages and disadvantages are there. Then the Python implementation is also there. Then summary of advantages and disadvantages. I've been able to prepare a table for you that you can see from there. Thank you very much.